Hello, everybody. So indeed, Nokia. So I had my, let me first do the typical English thing. Let me start complaining about stuff. So, so when I was making the presentation first, I was making in this, wonderful Alcatel template like 16.9, and then during, then I registered, and then my company changed into Nokia, so I had to redo the whole thing again with Nokia template. And then I realized template, the thing actually had to be submitted in 4.3 format, so I had to do it again. So nevertheless, it's here now. I hope it looks sort of okay for everybody. And I'm part of the Nokia crew since last Thursday, so it's all new. So I represent this new blue company instead of the purple thing. So what I'm going to be speaking about, and actually thank you, by the way, for putting me after peers here, because I think these two topics, they complement very well. And I actually believe that the privacy of a subscriber, goes very well with an operator's intent of tracking a particular subscriber, for the charging purposes and for actually making sure that a particular, user, subscriber here, gets the access rights actually which are, part of him. I think these things are not mutually exclusive. I think, it will be necessary going forward that the operator will only get that information which is important to him for serving his particular goal. So I think it's good work. So let me see here. So I think the animations actually are out of the presentation. Okay, but that's not really a big problem. So the way we actually have been seeing, V6, in a timeline perspective, is that, in around 2000, most of the backbones, they started to deploy IPv6, from a native routing perspective. And that worked out well, but not necessarily everywhere. And what we actually were seeing is that in some environments where, a network environment cannot be upgraded towards IPv6 itself, because you go over an infrastructure which is not, belonging to your own operational infrastructure. But you actually own little pockets on the side of the network, so you need to connect them together. And the way that is done is by like an overlay infrastructure based upon, 6P and 6V, VPE, by connecting these different pockets over, the V4 cloud with MPLS enabled as a service. Then going forward, people said like, okay, now we have V6, in these different parts of the network, but how do we actually enable IPv6 for business VPNs? And how do we actually enable it for residential customers? And that is what we have been seeing from around 2010. And that again works out pretty well. Now we're going to the next phase. How do we, and now we're actually asking ourselves the question, are we going through the rollout of enabling IPv6, in the mobile environment? And we're looking into like, okay, how do we enable IPv6, for carrier Wi-Fi? How do we actually make sure that a particular subscriber, is connected towards V6 Wi-Fi infrastructure and can make the uses, which he has been entitled to from his home residential subscriber service, and mixing and matching it all together. And that is where we are going through, right now at this point in time. And to facilitate that, so we have been working together with, mainly driven by Comcast here in the US, and they're now going towards community Wi-Fi and then enabling IPv6 services on top of it. So we worked together with them, and that actually has been the driver for this particular presentation. So the way the presentation has been set up is first I will explain a little bit about what is community Wi-Fi itself, and then we're going to go over some of the parameters which actually have been set, for the Comcast community Wi-Fi infrastructure to deploy IPv6. So again, this is public information itself, has been documented in an IETF draft. So what is carrier Wi-Fi? Well, we all know what it is. It is actually Wi-Fi infrastructure which you can subscribe to, which could be potentially part of your home residential subscription. It could be something you purchase transactional for a particular point in time from a certain provider. And it often comes from, maybe free of charge for a particular event. Maybe you pay for 24 hours, for 1 hour, these kind of things. So the way it actually works, and that is something which, before I started working with it was a big question mark for me because it sounded like black magic. It's sort of like, so what you're doing is the different access points, when you connect towards it, they actually identify, they figure out, this is a subscriber. And then all the packets which are there, they actually will be tunneled towards something which is like a wireless LAN gateway. And that will be so that device will actually check with this policy layer what to do with it. It will give it an address. And then it will start to identify that particular subscriber. This could be done through a captive portal, like what is used for Comcast. This could be based upon certificates or whatever, other kind of means. You are very flexible in that. But that is in essence how it works. So you connect to it. All your packets are then tunneled towards a wireless LAN gateway. He does the double checking of who is this particular subscriber, and then he gives you addresses and makes sure that all the traffic you're doing is accounted for, that you actually get the rights you have been credited to. So this is just a quick diagram of which are the different parts which are necessary for the wireless LAN gateway mechanism here. So the wireless LAN gateway sort of like sits between all of the different areas on the edge, which actually have like wireless connections. So also in the wireless environment, the user devices are called like UEs, like user equipments, and they may or may not actually have a SIM card. So depending on how you identify that particular user, it's sort of like depending upon the application realm you're looking into. And for what you're seeing is that is this pointer working? Okay. So the first thing that got into the V6 realm was actually the IP core edge. And the reason it is edge mentioned here is because often the wireless LAN gateway itself is sitting at the edge of the network. That thing actually speaks towards the policy and subscriber management layer, which was already IPv6 enabled in the second phase. The next thing what we actually saw is that all the connections towards home users, different locations and so onwards, start to become IPv6 enabled. And then the last step, and that's where we are right now, we actually start seeing like IPv6 to be enabled on all of the different wireless infrastructures. So, what drives the V6 implementation itself, and why we actually are seeing IPv6 on the carrier Wi-Fi infrastructure? Well, the first thing is we have a wide proliferation of mobile devices. And we actually have like way more than just those devices which are enabled with a SIM card. Any device which has a Wi-Fi interface, can actually be hooked up. So we have like really a lot of them. If we bring them, if we sort of connect them up to the Wi-Fi environment, they all need to have an address. Even if that device actually is not, purchasing your particular service, you still have to book an address for it. So you actually consume way more addresses than, you actually are using, which is, a potential problem. And one of the resolutions there is to actually use like IPv4 NAT. But again, that comes with complications. Complications being that you need to look into how many ports a particular subscriber is intending to use. You need to have some degree of tracking for legal purposes, because you need to identify if some of your subscribers are going to illegal sites for whatever purpose. You need to be able to backtrace them. And you also have like some potential fragmentations and reassembly issues if you send packets over tunnels that needs to be addressed. Another thing of inefficient address usage is that you have no way when a subscriber goes away from the Wi-Fi to free the address up again. So you block addresses, which is an issue. And you also have like pairwise master key caching is for fast connect. So you actually block addresses for a device which is roaming, like a Windows 10 device, for example, through different hotspots. And it can actually keep the same IP address. But for that, you need to reserve the address for a particular amount of time. Again, that brings in complications. So that really makes the, the problem for IPv4 addresses bigger, because you consume addresses which may not be used. So you can either solve that, or you solve it in a good way, which is like use a mechanism which actually has way more addresses available, which is the V6 realm. So V6 is the solution. Well, the first question is, can we live with V6 alone on the Wi-Fi environment? Well, you can in the future, but honestly, at this point in time, a lot of the content out there is still V4. So you still need to be able to access that V4 content. So you still need to have some degree of translation there, which doesn't really solve, one of your key problems, which is the addressing. Another reason why V6 only might not be, your method of preference at this point in time is that some of the devices, they start off with the V4 connectivity. And then later on, they add V6 next to it. This also means if you don't have V4, there will be no more V6 either. So something to think about. So the way we actually are going forward is, what we will see at most of the community Wi-Fi and carrier Wi-Fi environments is going to be a dual stack environment. So it will be V4 as what is happening right now. And what you will do is, next to it, you will provide IPv6 connectivity in a dual stack environment. So you will not change anything to the V4 at all. You will just add V6. And now we actually come to the section where, which was the motivation of this particular talk. Because if you add V6 next to the V4, you need to make a few decisions on what sort of addresses you're going to be using. Are you going to make, for example, the wireless LAN network one big shared /64? Or are you going to do something different? Are you going to be using DHCP? What are going to be the timers you would like to deploy for refreshing of your address? How are you going to be doing the tracking? So we're going to cover some of those things which have been documented in this particular IETF draft. So let me skip this one in the interest of time. So, by the way, you will find a few more slides also, if you go and download them from the deck itself. I've added more content, on there than what I will be discussing here about, mainly, to serve you as a reference guideline, afterwards when you go back home. So, these best practices for IPv6 deployment for community Wi-Fi and carrier Wi-Fi have been documented in this particular draft here, and they're actually driven upon the Comcast use case. In this for this use case, what is being done is that every device on the Wi-Fi network will get its own /64 address space. So if I have a mobile phone, for example, I will get like a /64 address space. If you, for example, have another mobile phone, hopefully not mine, if you have another mobile phone hooked up to the Wi-Fi, you will get a different /64. So you will actually have a different subnet. So you will not belong to the same, prefix range. So in V4, if you would get like a /64 on a particular LAN network segment, then a different Wi-Fi subscribers will be directly attached on the same subnet. In V6, that is going to be different. What is being deployed here. So each subscriber will get his own /64 subnet. How that subnet actually is used to form the 128-bit address is sort of dependent upon where you are in the deployment time frame. And it probably depends also upon the capabilities of your device. So what Comcast actually has done an investigation, and they have figured out that the most common denominator for V6 capabilities for these kind of devices is that not all of them support, DHCP V6 for address assignment. They support stateless auto-configuration. Most of them actually support DHCP for getting information like a DNS server and NTP and these kind of things. So what they are doing is they sort of like set up particular, parameters in the right way. So I'm going to be discussing about these, about these parameters and about this timing. So, quick overview of what we have here is, so on the diagram, we actually see we have our user equipment here that is hooked up to an access point. The access point is connected through the backhaul network by something which is called like a soft GRE. So what is a soft GRE? It's like a GRE tunnel. So in this case, the wireless LAN gateway is just a GRE hub interface. It will accept any GRE tunnel request it gets from a particular approved range. So it's hub and spoke situation, just GRE tunnel. So the access point will just bridge the packets from the user equipment up on the tunnel. It gets into the wireless LAN gateway, and then he will do some magic. He will actually check what is the address range given for that particular user. He will actually send arrays, unicast arrays to the, advertisement, yes, towards this user equipment for the address range and so onwards. It will be connected towards a captive portal potentially, and it will be connected towards a policy layer through radius for making sure that everything is accounted correctly. So if you really want to have lots of fun, go and read the draft here. So this is actually all of the communication going back and forward for making this happen. So let me, in the interest of time, make this, do a few slides into one actually as such. So in essence, what we're seeing is from the moment that the user equipment connects, it actually asks like, who are the routers on my network? You do not see the access point here. Because in essence, it is only a bridge. It bridges traffic from the wireless up on the GRE tunnel towards the wireless LAN gateway. So the wireless LAN gateway is our smart device in this case. So he sends a router solicitation, asks like, okay, where are the routers? And tell me about what is my prefix and what should I do to get an IP address. The wireless LAN gateway says like, cool, I have this guy here connecting to me, but I have no clue what it is and what sort of address I need to give it to. So he actually checks with his policy layer. His policy layer would be his AAA server, and it says like, okay, well, you can give him this address. So there are like two ways for the policy layer to decide what sort of address it is. Either it gives an address by itself and make its own track, or it uses an address range configured on the wireless LAN gateway. That is, up for choice. But in essence, it sort of allocates a /64 for that particular subscriber. So the wireless LAN gateway gets the information back from our AAA server, and then it constructs our router advertisements. So the way he constructs it, he actually adds two parts. One is the IPv6 prefix, the /64, and he also adds a few flags. These few flags actually tell the user equipment how to use that particular prefix. Does he have to use DHCP? How does he create the 128-bit IPv6 address from that particular prefix? So once that is done, let me go there. So that's what I was saying. So in the array, we have two chunks. We have the v6 prefix, 64 bits, and some flags, and that is what is specified here. So which are the flags? So we have 4 flags of importance. The way they actually are going to be set in a Comcast environment is like this. So we have the M flag set to 0, which actually means that we do not expect that this address for that particular end user is going to be managed through DHCP. So we don't have the expectation that the end user is going to be supporting DHCP v6. We also set the L flag to 0, which is the local flag. So it actually means the end user thinks he's off-link. So to connect to any other device on the same wireless network, he will actually send the packet first to the gateway instead of sending it directly, which it would do anyway because the neighbors actually are /64. They are different subnets. But this is just, in case you would be using the same /64 for everybody, you can still fiddle around this way. It's based upon design decisions. I think it is good practice to avoid misbehaving in user equipment devices. We also set the O flag, is the other parameters flag, to 1. This actually means that if an end user has an IPv6 address, he still doesn't know where is a DNS server, so you need to get it from somewhere. That is what this flag is setting here. It says like, okay, use DHCP v6 for getting your DNS server. And it also sets the A flag to 1, which actually sends the Wi-Fi device, the subscriber, to use stateless auto configuration for using the 64 bits. At 64 bits by itself, could be privacy extensions, could be based upon the MAC address, could be based upon Voodoo, could be based upon whatever. As long as 64 bits plus 64 bits forms 128, the whole mechanism actually is happy. So, yeah, this is sort of like saying again, like, what different bits are doing here. Again, you have like, two different ways for getting a DNS server address. The most common way, what most user equipments support, is like getting a DNS server through the DHCP, information request. In v6, you have another mechanism also, which is like, putting the DNS server IP address into the router advertisement itself, which is called like RNDSS. So we're almost to the end of the talk here. So some of the other important parameters which actually are used for the use case here, in the US, is so they are putting in these different, values for IPv6 neighborship discovery timers. So this is what we have tested in the lab, with all different kinds of user equipments, and it seems to be working reasonably well. So we actually have, a router advertisement interval of like 300 seconds. The router lifetime is like 3,600. Reachable time, 30 seconds. You can use 3,600 seconds. The IP address you get is like valid for 3,600 seconds. It's like 1 hour, I believe. And the preferred lifetime that you can initiate sessions with that IP address is like 1,800 seconds. And the retransmit timer for like neighborship discoveries, time between different ones is like 0, so you can send them as quickly as possible if that is what you want. Another element also, again, sort of a little bit correlated with the previous talk, is that it is often important for operators to understand where a particular subscriber is at. Now we have like two ways of doing this or achieving this particular goal in community Wi-Fi, carrier Wi-Fi environment. One is if you have the capability of using DHCP, you can actually insert an interface ID within their identification mechanisms of where is this particular access point, so you have awareness of that. Another way would be if the end user is not capable of using DHCP, so you cannot insert an information, you cannot do that. Then you need to harvest it through another mechanism. And then it is based upon like, what the wireless LAN gateway is capable of doing. So a way of achieving that is by doing neighborship discovery over GRE. So by doing that, you can identify where is the endpoint of the GRE address. You get a MAC address from that. And based upon that, you can actually check in your tables, MAC address tables, and identify where this particular access point actually is at. So of course, going to the end because I have 1 minute left, is for v6 you can do identical the same services as you can do for IPv4, so there should be no different. So if you have v4 implemented and if you got dual stack, you should do the same things for v6. And the other thing what you can do, for example, is you can do like like voice over Wi-Fi. If you have like an Apple phone, you can use the community Wi-Fi to get like an internet connection, and then based upon the IPv6 internet connection, you can actually send up like an IPv6, Apple Wi-Fi calling. You actually make a phone call over the Wi-Fi infrastructure by an IPsec tunnel you have created over the IPv6 infrastructure. So that's it. So what does v6 bring to carrier Wi-Fi? You avoid NAT. That's very important. You avoid NAT. Less logging, less trouble, less pre-planning, and so on. It's just easier. And by going dual stack, the integration is easy because you don't have to break anything. You just complement what is already working, and you extend it. So it's hitless. And of course, you need to take a few, particular things of IPv6 into account. But I've already covered at least the addressing perspective of how addresses are assigned. So that's it. Thank you.